Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. We'll just solve more examples in this video. In the previous one, I introduced the concept of area under the curve that's entirely above the x-axis. I wrote down the rules. Now I'm gonna just add like maybe one more example, okay? Or maybe I'll just do two more examples here. Then we'll now move to the next type of area under the curve that is below the x-axis, okay? Before I proceed, please don't forget to like, share, and subscribe. And if you've not clicked the notification bell, please do so that when I post new videos, you'll be the first person to know. All right, so let's solve this question here. Let's assume we have this. So for example, okay, we're told to what? Calculate the area bounded by the curve y is equal to minus 6x squared plus 24x plus 11. And the x-axis is bounded to the x-axis at this point. And the ordinates is x is equal to 0 and x is equal to 2. Okay? So x is equal to 0, x is equal to 2. So if you've sketched this curve, so basically you will see that the curve will look like this. It will look like this if you sketch it, okay? And we are interested between x is equal to 0 and x is equal to 2. So x is equal to 0 and x is equal to 2. So we're interested in this part of the curve. Okay, so what do you do? Step one, the first thing we do, we know that the area has to be positive, right? So please make sure you watch the previous video. I wrote down the 5 steps, okay, on how to do this. So please make sure you watch it because this is just a part 2. Here, I'm just solving more example, all right? So here, we already know that the area is positive. So that means area must always be positive. We need to always remember that. Now, step 2, okay? Step 2 is that we need to also know that because we are going to be integrating this between 0 and 2. So the upper limit here is going to be 2 and the lower limit is going to be 0. And I told you that the integration of, or the definite integration of a curve gives you from that curve to the x-axis. So now, but we're only interested from 0 to 2. So that means we're going to integrate between 2 and 0. We're going to integrate y. Is that making sense? So that means basically we're integrating between 2 and 0, the y, which is what? Minus 6x squared plus 24x plus 11, all right? So I will really strongly advise at this point that you should go back and review my videos on how to integrate. I think I gave 16 rules on how to integrate. So please go back, have a look, and make sure you know how to integrate. So let's integrate this. So remember I told you when you're integrating, you add 1 to the power divided by the new power, right? So let's go. So we'll add 1 to the power. So it's going to be minus 6x. 2 plus 1 will give you 3 divided by 3 plus. So remember I told you that this is something as x raised to the power 1. So it's going to give us 24 x raised to the power 2 divided by what? 2. Are you seeing it? Plus. And I told you when you integrate a constant, it's going to give you what? 11x. And all this is between what? 2 and 0. Making sense? Then, if you want to simplify this, you can simplify this, but I'll just use it like that. Then the next thing I told you as well is that you have to then you have to then substitute the upper limit to get an answer, to get the y1. So step 3, we then need to substitute the upper limit. So anywhere you see x, you put 2. So it's going to give you minus 6, 2, 3 divided by 3 plus 24, 2 raised to the power 2 divided by 2 plus 11 what? 2. Now, when you substitute this, the final answer you will get is what? 62. All right. Then, step 4, the next thing we now have to do is that we have to substitute 0 into this as well. So it's going to be minus 6, 0 cubed divided by 3 plus 24, 0 squared divided by 2 plus 11 what? 0. And that'll give me what? 0. Okay? Then, that's that for that. So step 5, what's the next step to do? I told you is going to become y1 minus y2. So it's going to give us 62. All right, so it's going to give us 62 minus 0, and that will give us 62 units squared. And that'll be the answer for that. Okay. Let me pick maybe one more for this. Let me do one more for this, one more example. Let's say we have this question here, number 2. Let's say we have we're told to calculate the area under the curve. We have y is equal to exponential 2x between x is equal to minus 1 and x is equal to what? 0.5. Step 1, the area is what? The area is positive. Okay, so the first thing I can also say here is that we can sketch this. So I showed you how to sketch an exponential graph as well. So I'm not going to talk about it. I'll just sketch it. So because of at this point, the value here, so it's going to exponential graph going to look like this. Okay. And well, interested between minus 1 and 0.5. So we'll call this, let's assume this point here is minus 1. And let's assume this point here is what? 0.5. So we're interested in this area bounded between them. And we're told that this curve, the curve here is going to be y is equal to exponential what? 2x. All right? So good. So step 2. So we're interested between 0.5 and 1. So that means we're going to integrate the curve between 0.5 and minus 1. So the upper limit is going to be 0.5. The lower limit is going to be what? Minus 1. So basically, we're going to integrate between 0.5 and minus 1 exponential what? 2x. So please, you need to go back to my videos on how to integrate exponential curves. So I told you how to do that. So the first thing you do is that you differentiate the power to give you 2, and then you now divide the original question by your answer. So it's going to be exponential 2x divided by what? 2. And that will give us between 0.5 and -1. So step three, the next thing you have to do, I told you that you have to substitute the upper limit. So this is going to give us, so anywhere you see x, you put 0.5 to give you exponential 2, 0.5 divided by 2. All right. And when you press your calculator for that, it should give you 1.359. Okay. Then step 4, we do the same thing. But in this case, we're going to use -1. So it's going to become exponential 2 minus 1 divided by 2. And when you press your calculator for that, that will give you, so that should give you, so you can still write it in the form of e minus 2 divided by what? 2. So you can write it that way. So when you press your calculator for this, it should give you 0.068. Okay, 0.068. Then step 5, which is the final step, we're gonna subtract step 3. That's I said that's y1 minus y2. So it's gonna be 1.359 minus 0.068. So it's 359. And when you press this in your calculator, it's gonna give you 1.291 unit what? Unit squared. I'll give you 1.291 units squared. All right, so that's that for that. All right, so that's how you find the area under the curve entirely above the x-axis. So basically, you can go to the worksheets and the textbook and take extra questions on this and practice, but just always know that the area has to be positive. Now, the next video I'm going to talk about is what about if the area under the curve we're looking at now is now below the x-axis? Now, what we've been looking at in the last video and this video as well was the area of a curve entirely above the x-axis. So the next video will be area of a curve entirely below the x-axis. So how do you go about it? All right. So I'll see you in the next video. So it's important to subscribe so that when I post the next video, you'll be the first person to know. All right. So I'll see you soon in the next video.